Okay.
Okay.
I think we're going.
I think we're going.
So
So this is the first stream
for
for
this
this
3D modeling
3D modeling project that I'm doing.
Thinking about calling
Thinking about calling it
Wilkerson Customs,
maybe Wilkerson Designs.
I used to call this
I used to
stuff
call this stuff that lives in my head Wilkerson Customs when I was a little kid.
So these are all the designs
that
have been living in my imagination since I was a little kid,
and
I
haven't had the
3D
3D modeling skills to get them onto the computer until now. So here we are.
This is an
Ultra 4
race car that I'm
modeling.
It's a
design study to see
if
I can get
the same
suspension geometry that's in Can-Am Maverick R
scaled up with the
the biggest tires available. Mickey Thompson 58s.
These giant
things.
So this was
my first draft at it.
I found this really cool
model for a
Hemi
supercharged with
Zoomy
exhaust pipes, which are really cool.
This is a
PPG Tremec sequential transmission
and
Atlas transfer cases at the front and rear. So
a lot of
Ultra 4 stuff. The engine is mounted backwards, and then the transmission is mounted in front of it.
And
then the primary output of the transfer case goes to the front differential, and then the
secondary
output of the transfer case goes to the rear differential. So I have two matching transfer cases here, one here and one here. This is
mostly just to
jog the axle, jog the drive line back to the center.
These diffs
are really cool. This is
from an
Australian company called Proformance,
and they have
3D models.
Well, at least they used to have
them on their website, and I downloaded them when they still did.
It's a narrow
diff Dana 80 where you can mount the CVs
as close to
the center line as physically possible, and then
the pinion gear
goes around those.
I don't actually know
if these
have differential
gears inside of them. They might be spool gears, but
this thing's
designed for rock crawling, desert racing. So
you don't really need
diffs, in my opinion.
And then I've got
brakes mounted
to the input shaft
of the third member. And
the reason for that
it's kind of like Rockwell style, where they just
it increases the
leverage. So if you imagine this is like a 5.9 to 1 gear ratio on the diff, and then
these are
portal axles, which are
2 to 1. Then you have a
10 to 1
or 12 to 1
gear reduction by the time it gets to the wheel. So
I think the
theory behind that is it's less stress on the drive shaft and therefore less stress on the brake.
Because if
this little tiny brake was trying to slow down this big giant wheel, it would be way too much torque. But if this little tiny brake is trying to slow down a really tiny
drive shaft that's
moving really fast,
that's better.
So I think. So
inspiration for all this
is some of my other designs,
which I'm going to do
another video on. And
this company called
74 Weld.
Really cool too. I just reached out to them and asked for a CAD model. And they sent me this shell. This one here. So this is what they call their 4-gear race portal that they use for trophy trucks, four-wheel drive trophy trucks, which is kind of a new thing. And then Ultra 4 independent suspension race cars,
which is
new as well.
And as far as I can tell, the
Ultra 4
guys and the trophy truck guys are running the same style portals
with the same
style drivetrain with the reversed
engine
and
transmission.
So
what we're doing today is we're
rebuilding this entire thing.
When I
first designed it,
I set the
wheel
track width
to be 10 feet wide, which is way too big. I mean, it looked right with these gigantic tires, but it's not realistic in terms of trailering,
and
it wouldn't fit down any trail imaginable. Besides like open desert.
So like Jeep
tip trails would not be a thing.
So maximum
DOT vehicle width is 8.5 feet, and
a lot of the
solid axle
rock
crawlers
run Dana 80s, and then they have big giant wheels,
which are 8 feet as well. So
things that I need to
redesign
the upper and
lower control arms because they're going to be narrower. The
knuckles because
just in the last couple of days I learned a lot about
kingpin
angle
and inclination.
I
learned a lot
about steering
and
Ackerman angle.
I learned a lot
about bump steer,
and this is
basically all wrong.
Learned a lot
about wheel offset.
This
is definitely wrong.
And I already
knew some about hub design.
So this hub design
is based off of a Camberg Racing
trophy truck
hub.
And
the
way that this
works is
there's two
bearings here
that ride on the
snout. So the snout is static.
These bearings
are attached to
the hub rotor.
And then the hub rotor houses the
wheel studs. So yeah, there's
a lot of things wrong with this design. Primarily being there's a ton of leverage, like the distance between
here and here
is too big.
These bearings
are unnecessary because this is intended as for a driveline axle, but
it can just be floating.
Also, I'm noticing for the first time an interference here between
the hub rotor and the lug bolt. So that's wrong. And I basically just need to
redesign this entire thing to
compress
all of that in
and make it right. The way that the
74 Weld guys do it is they use
a different style of
hub,
which is called a
unibearing, which
as far as I can
tell
on the internet.
So this is just a shell.
So these are all just
surfaces. You can't actually see any of the thicknesses of the material, but
they have a really cool
breakdown
of their four gear race. That looks like this. So you can see the way that they do this is they have this
unibearing, which is like a standard bearing. So it's got 4 bolts on the static part of the hub, and then 6 rotor, 6 lug on the rotor,
and then there's
this really big bearing in the middle.
If you look at
unibearing hub cross section,
that's what
these look like. They look like this.
Right.
So
what you're seeing
here is
the
bearing
rather than being two separate
bearings to account for the
moment arm.
The moment arm
is just one
really big wide bearing with 2 races.
So it has
one outer race and then 2 inner races, and then the hub in between.
So
So I'm not going to design all this because these are just like OEM parts.
It's like what I would want.
It's like what I would want
for this design
would be like a
Dana 80 unit bearing hub. Something like that.
Something like that, like an 8-lug.
Super Duty F350 Dana 80
8-lug.
And those look really fucking strong. Yeah, so these what are these bearings called?
They're not neat.
Are they needle bearings?
I think they are. My initial design
I was
using
needle bearings spaced out really far, but I don't think I need that.
I think what I'm gonna do is
take the dimensions
from this and just scale it up. So
I'll start with a mock-up
of this hub
converted to an
8-lug pattern.
Make the
mock-up for this stator on the hub,
and then start
building a portal housing around that.
So the
complicated part is going to be
getting this
tall knuckle design
to line
up
so that the kingpin
inclination angle, which is from your lower controlling to your upper controlling pivot points,
is in line
with the center of your wheel, and ideally the center of your wheel is in line with
the center of your
hub as well. I don't think that's going to be possible in this application because
you need a crazy
negative offset like you would need.
I don't know,
or you would need to move this thing way down here. But
again, the inspiration for this is if you look at the
Can-Am Maverick R front suspension.
It's really cool.
The way that they've designed this.
Yeah. So basically,
the idea is when you have a side load. This is confusing. When I first saw it, I'm like, why would they do this? Is it just meant to look cool? There's actually design reason behind it. So
this is
probably a good explanation.
So when you have a
side load on your wheel,
when you're turning,
or whether you're hitting a bump on a side load,
the force
on this pivot point
is represented
by the moment arm of this distance, 10 inches.
Now, in a
standard design
like this, the force on
the upper joint
is the moment arm
between these two guys. Right.
Between the
upper control arm and the lower control arm.
And if the
distance from here to there
is longer
than the distance from here to there,
then
this moment arm gets amplified.
And so basically
the reason
that they
move the upper control link pivot point way up there
is twofold.
One, it reduces the moment arm
force
on this lateral load on the upper control link,
and also
it brings the kingpin angle
into center line
with the wheel,
which has
a ton of benefits.
There's a
YouTube channel called Shock Therapy that has a really great explanation of not only how the Maverick R
is designed,
but
front suspension
in
general. And
so
after I watched
that video, I realized I need to completely redesign this entire thing. So
that's what I'm doing today.
I'm going to start with a wheel
and work my way
in from there. So
the first thing I'm going to do
is
save as
new.
Rev 2.
I had a mechanical engineer tell me revisions are free.
Actually, he said
numbers are free.
So
you can have as many rev files as you want.
Save as copy
and open.
And then we're going to
leave the other one open.
So I guess
through the course of this, I'll be talking about
some SolidWorks
best practices that I've picked up over the years.
So one weird thing
about SolidWorks is
when you save
as, you basically have 3 options. Do anything else with
save
it.
as copy and
save as copy and open is what we're doing now. So I'm gonna have 2 duplicates of the same assembly.
And what I want
to do
is
keep the original document open because I'm going to be referencing that.
Most of the time,
if it's a component and I want to save as new and make a completely new revision, I'm going to close the original document so I don't accidentally edit the wrong one.
But in
this case, I'm going to be
referencing
and copying over
a lot of hardware
components
like these
spherical bearings and stuff.
And so I want to reference
that. So
the first thing I'm going to do
in this upper assembly
is delete
all the stuff that I don't want to keep. So
basically
the only thing that I want to keep,
I think the only thing I want to keep
is like
the
drivetrain.
So this is going to go. This is the old upper control arm assembly. Front lower
A-arm.
These axles,
because those are going to get way narrower.
Actually, I'm going to leave those in because I think that's fine. These wheels. Wheel assembly. The portal hub. I'm going to keep the diff, the transmission, the engine, some of these axles, the Atlas cases, wheel, portal, wheel, portal. And then this wheel and portal as well. I'll delete all of you. So I'm going to be making new ones. And the seats. That's kind of it. So I decided I wanted to try stadium seating on this. Primary reason was
I wanted to get three seats in the back.
And the only way to do
that was to move the center seat on top of the transmission.
So this
has a couple of benefits. Like first,
you can
see how low this thing is when it's riding on 58s.
It just looks really narrow. It looks really short.
I mean,
like
the top of this upper control arm is above the driver's head.
It's like that's aesthetically goofy.
So
the stadium seating. I'm
going to be able to do a bunch of cool stuff with the tubing.
Which is probably going to be the last thing I do.
But I took some inspiration from these
rock bouncer guys that live on
the East Coast, like the Southeast.
And they do these crazy
custom builds.
There's this one YouTube channel called Mad Ram that I really like.
Yeah, here it is. Check this thing out.
This is one of the builders
called Angry Fab.
I really like
these curved
hoops and
loops and
all this tubing.
Just looks amazing.
So
the guy from
was it Grindhard
Plumbing says no straight lines.
Like if you're designing something,
make it look cool. And
I've designed some
other stuff like
I
designed a road-going version of an independent front and rear suspension vehicle, which I'll make another video about it.
There's a lot of straight lines.
There's a lot of straight lines in the tubes, and it had all this really awesome suspension, and then the tube work just ended up looking like very goofy.
So I think. So again, I'm using
the
Mickey Thompson
58-inch tires.
So these are 58 by 21
on a 24-inch rim.
So the first thing
you need to do
in order to redesign
the wheel
is to capture
these dimensions. So what I like to do
is go back to my sketch and just screenshot
these dimensions.
And then keep this open
in another
display
as a reference.
So I know I have a
24-inch rim.
I decided on.
I made up some of these dimensions, like
the
three-quarter inch thickness on the bead lock, the 1-inch height on that rectangle,
the 1-inch
thickness on the sidewall, and the 2-inch thickness on the belt. I don't know if any of that's right. It's close enough for a mock-up.
So I've got that. And then the other thing that I did
incorrectly
was
this wheel design was like
completely wrong.
Like this is not how wheels are made. I'll show you what I did.
It's way too thick.
It's probably way too heavy.
It's overbuilt where it doesn't need to be.
We'll pull up a cross section of this. I'll show you.
So the beadlocks.
I'm confident in that part of the design, but
almost everything else is wrong. So yeah, the offset
was like right in the center,
which looks
cool on lifted trucks, but is not good for off-road.
This part of the
rim is way too thick. This part of the rim is probably close to the right thickness. I think it's either 1 or 2 inches. Let's see. 1.5 inches. That's fine, I guess.
And then these
guys. Let's see what.
The quarter 20
and 12-point screws.
That
looks right to me. So let's figure out where our bolt pattern was to keep that in our head.
So
this was 8
on a
6.5 inch diameter, which is nowhere near right.
So let's look up
Dana 88 lug bolt pattern.
8 on
170. Is that right?
8 on 170.
8 on 170.
8 on 170.
8 on 170. Let's look up F350
pattern. 8 on 170.
8 on 170. All right, cool. So there we go.
So we're gonna keep that
in our head, and we're gonna make a new rim.
So I'm
referencing raceline wheels,
forged double
beadlock. No, that's not quite what we want.
So Raceline doesn't make a 24-inch double beadlock, but I am going to offer beadlocks. Forged. And so you can see kind of the shape here. It has these like dents that I can't get a good read on. Then they have this cross section here, which I don't think that's actually how they design it either. So I'm going to be taking this image
and trying to infer what those dimensions
look like. For the sake of simplicity, I'm probably just going to make it flat on this edge.
Oh, that's interesting.
So they have the
bolt.
Let's look at more. Bead block wheel cross section.
Let's see what these look like. Okay, that's not it. Bead lock wheel diagram. So these guys have the bolts
on the inside.
Inner bead lock
weld on ring. Okay. Method. Race wheels. Bead lock install guide.
Okay. So
this is how Method does it.
Let's see what
Method has these days. Bead lock wheels. They just did it.
Okay, so they've got
their
bolt holes on the
inside of the bead.
And then their
bead ring
goes around
there, and then a bunch of 12 points.
Here it is.
Perfect. Shit.
All right, cool. That's great.
That's
exactly what we need.
Exactly what we need.
Take another screenshot
of this.
I'm gonna open up that
other
screenshot that I had.
Put it in a paint window, and then I can have multiple screenshots open. All this. I wonder what that little grippy guy is there.
That's interesting.
That's a nice
explainer
video. So they have grade 8. So you can tell it's grade 8 because these little 1, 2, 3, 4, 5, 6. They have these little demarcations on the top. That's how you know it's grade 8.
Grade 8 bolts
are super duper strong. Reason 12 point because they look cool.
T6
heat treated.
Zinc plated.
Bead lock ring.
I wonder if Method makes a
24-inch bead lock.
What was that
thing about head shearing? Machined grooves.
Interlock
with tire bead to prevent tire rotation and extreme torque attraction. That's crazy.
Those
are just like little
drill holes.
That's super interesting.
Yeah, so
I really like the idea of a double bead lock,
especially for rock crawling.
Because like if you're crawling up on a rock, and your tall tire is resting on a rock, it could pop that inner bead easily.
I'm sure it doesn't
happen that often, but
because almost nobody runs
double bead locks, but the super hardcore
rock bouncer
guys do.
I think a lot of them run
custom wheels.
Should look into that too.
Should look at rock bouncer wheel suppliers.
Let's see.
So they got these guys.
3.
These are just their different styles, I presume.
I love that look. I had the fake bead locks like this on my truck.
They look sick.
Just the Baja wheels.
This is probably
what I'll end up designing because it's just
concentric
hole or
radially similar holes.
Probably just do that.
Yeah,
they only make 17s.
Let's look up
rock bouncer wheels, beadlock wheels, and see who's buying ads for that.
Problem is, this is a new and annoying thing.
Whenever I Google image search stuff, I just get a bunch of RC. It automatically goes to shopping,
and it just wants to
sell me a bunch of remote control stuff. I intentionally avoid remote control content on Instagram because I do not want to be marketed. Let's look up busted knuckle or these guys build crazy rock bouncers. Let's see what kind of wheels they got.
Almost everybody's
going to be running a
17-inch
wheel.
These are race lines.
229. Trail ready beadlock wheels. Single beadlock. Raw sandblock wheels with machine bead ring. Beadlock cast. Forged. Let's see what these guys got.
8 on 6.5.
What's
Okay, that's a different
bolt pattern, but I think we're going to use the Dana 81 because it's easier. Let's see what these guys are running. Backspacing, pattern 8 on 170, 8 on 180.
17 by
8.5. Well, we're just going to have to make them ourselves. Okay, so IPS front plane. Oh wait, we need to go back.
I need to take another
screenshot of that. Hopefully that's not copyrighted. Here we go. It's fine. Okay. So front plane. First we're going to map out the wheel.
Map out the tire.
So the tire I have set to 24-inch diameter. And the outer width was
16.5. So that's a good starting point. And then the bead
itself.
I'm going to draw
two of these.
3/4
inch by 1 inch.
So that's what we're going to be
bolting to. Construction.
I feel like that's enough
intro. I'm gonna lock in and turn on some tunes. You guys can watch. We'll go to time lapse for the edit.